Good morning, sir. Good morning, Vita.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning, Vita. Good morning.
Good morning, sir.
Good morning. And now I'll start the class because most of the members are there. 100 plus is there, means it's enough for me. It's enough for me. One more example is left over. One more example is left over. Is a very famous example. It is there, and that is the reason why it is not possible for me to neglect that. And therefore, I will take that example, and then I'll go for our Faraday's law. Faraday's law won't take much time, as I have mentioned to you yesterday. Faraday's laws won't take much time. So last example left over is our So last example of electrolysis is our electrolytic reduction of alumina. This is very important question coming in the examination. Alumina, ALUMINA, alumina. Al2O3 is called as an alumina. It is there, and this is also called as Hall's and Herold's process. Hall's and Herold's process. So you say Hall's and Herold's process, or you say technically called as an electrolytic reduction of the water alumina. It is there. So first in this I'll go for the electrolyte. In this I'll go for the electrolyte, not going in tabular form. Electrolyte is Al2O3. This is our main electrolyte. It is there. And in this we are adding Na3AlF6. Na3AlF6 we are writing, or we can write this as a NaFAlF3. We can write in this way, and this is our CaF2. It is there. CaF2 also called as a fluoride, or fluorspar from the topic metallurgy or from topic second A group family. Now question arises, if this is the main electrolyte, it is there, what is the purpose of adding this to? Problem of this main electrolyte, it is there that it's a fusion temperature. It's a fusion temperature. Fusion temperature means melting point. Its fusion temperature is very high. 2050 degrees Celsius. 2050 degrees Celsius is not a joke temperature. It is there. It's a very, very high temperature. It is there. And the melting point of the aluminium is roughly 1700 degrees Celsius. Melting point is 1700 degrees Celsius, and this temperature melting point is 2050. So if you will maintain this temperature, at this temperature, all the aluminium will undergo vaporization. And a company will become bankrupt. Company wants a solid aluminium. Company does not want gaseous aluminium, and therefore this temperature we don't want. And moreover, in addition to that, maintaining such a high temperature is a costly affair. Therefore, deliberately we are adding these two impurities. Both decreases fusion temperature. And this is from the concept of solutions and colligative properties. What concept I have taught you? When any impurity it is there, impurity increases the boiling point, and impurity depresses the freezing point. Freezing point is also called as a melting point. So whenever the impurities will be there, because of this impurity, freezing point or the melting point gets what? Decreased, and therefore fusion temperature decreases. Now coming for this one, it increases conductivity. So job of this cryolite is both. It increases conductivity as well as it decreases fusion temperature. The job of the CaF2 is that it only decreases the water fusion temperature. It is there. This is regarding the electrodes. If I am going for electrolytes, if I am going for electrodes, electrolyte forward, if I am going for electrodes, so definitely two electrodes will be there. Cathode will be there and anode will be there. Graphite rods are behaving as suspended. Suspended graphite rods are behaving as a what? Anode, they are hanging. That is the reason why called as a what? Suspended. It is their cathode. Steel vessel or maybe iron vessel. Steel vessel coated by carbon. The vessel in which electrolysis is occurring, the steel vessel or the iron vessel, it is coated by the what? Carbon. This steel vessel or the iron vessel which is coated by the carbon, it itself is behaving as a what? Cathode. It is there. Anyone doubt in this point? Shall I rub this one?
Yes.
1 minute.
Yes, sir.
So whatever the handwritten PDF file I am giving to you, for that print copy should be there in your hand. Then only it is having any use. Then only it is having any use.
So what did you write before vessel, sir, in the cathode? Before vessel, sir, in the cathode.
Steel vessel.
Steel vessel. Steel vessel below iron. So maybe steel vessel, maybe iron vessel, coated by carbon. Steel vessel or the iron vessel coated by carbon. The vessel itself is behaving as a cathode.
Done, sir.
Right?
Yes.
Yes, sir.
Yes,
Done,
sir.
sir.
Now I'll give you a rough diagram. By this diagram, you will get imagination what I am going to portray. Otherwise, if diagram I won't give, you will not imagine what is this cathode, it is there, what is this anode, it is there, what is the meaning of this suspended electrodes are there. So rough diagram I am giving to you only for understanding part. Carbon coating. Steel vessel coated by carbon, which is behaving as a cathode. This is our suspended graphite. And this suspended graphite is behaving as an anode. Here we are having a mixture, electrolytic mixture, Al2O3, Na3, AlF6, and CaF2. Electrolytic mixture it is there. This electrolytic mixture, I am writing electrode something more down. This electrolytic mixture is covered by coke. This electrolytic mixture is covered by coke. Why covered by coke? After electrolytic reaction, we will get aluminium. From third A group family, you are having a very clear idea. Aluminium is having very high affinity towards atmospheric gases like oxygen and the nitrogen. So whatever this coke powder it is there, coke powder is behaving as a barrier. Whatever the atmospheric air it is there, it is not allowing the atmospheric air to go inside. Why? Because if atmospheric air is going inside, whatever the ultimate product, aluminium you are getting, that aluminium is combining with oxygen and giving Al2O3 and aluminium nitride. Aluminium oxide and the aluminium nitride are undesirable product. We don't want this much money we are spending to get aluminium metal, not aluminium oxide, not aluminium nitride, and that is the reason why this coke is sprinkled on the surface of the electrolyte. What is the job of this coke? It does not allows the atmospheric air to go inside. Now I'll go for the reaction. This I'm rubbing it, shall I?
Yes, sir.
Okay.
So now you have got the idea how the diagram looks. Now I'll go for the reactions. Cryolite 3ANFALF3 on passage of the current, it decomposes. Our aim is to make aluminium, and this is only giving aluminium, this is not giving aluminium. So I won't write this reaction. I will write reaction which is bothered regarding the aluminium it is there, and therefore I'm writing this reaction only. For balancing, I will take. For balancing, I will take. For balancing. Now I'll go for the cathode, and now I'll go for the anode. Cat ions is coming towards cathode. Anions are coming towards anode. In this case, preferential discharge does not comes in picture. Why? Competition is not there. It is not an aqueous form. It is proper fused form. It is proper fused form, or the water molten form it is there, and therefore preferential discharge is not occurring. 6F2 plus 12 electrons it is there, and this is called as primary anodic product. Primary anodic product, or the main product, it is the primary anodic product. These 12 electrons are coming here, and it gives rise to 4 moles of aluminium. Very common question comes in the examination. Very common question comes in the examination. What is the ratio of the cathodic product and the anodic product? What is the ratio of the cathodic product and the anodic product in Hall's and Herold's process? So this is nothing but our 2:3. Can I say?
Yes.
Yes, sir.
So cathodic is to anodic is a 2:3. In the examination, suppose if it is asked ulta, anodic versus cathodic,
3:2.
Please do.
that's all, 3:2. This is a very common question coming in the examination. Now coming for this fluorine, the primary anodic product. Now this fluorine is going up. Why going up? So it is a gas. Fluorine is a gas. It will move up. Gas will move up. And when the gas is moving up on in its path, this fluorine is combining with Al2O3. Check till now, nowhere in the reaction Al2O3 is used. Till now, nowhere in the reaction Al2O3 is used, and it gives rise to AlF3 and the oxygen gas it is there. It gives rise to oxygen gas it is there. So therefore, if I am going for the balancing, here 2, I will write here as a 2. So now it is becoming 3 2s are 6. So now here I will write this as a 3. Now coming for oxygen. Now coming for the oxygen. Tell me, oxygen balanced or not?
No, sir.
Therefore, what I will do here, this I'll make it as a 4. This I'll make it 2, and this I'll make it as a 6. So 3 4s are 12. 3. Can I make it here 3?
Yes, sir.
Yes, sir.
Now this is nothing but oxygen. Oxygen is our secondary anodic product. Secondary anodic product. It is a primary, and now it is what secondary. And whatever this oxygen is a gas, oxygen gas is also moving up. When oxygen gas is moving up, it is combining with It is combining with graphite. It is combining with graphite. What graphite? Graphite electrode. Is combining with graphite electrode, and it is converting the graphite electrode into carbon dioxide and the water carbon monoxide, and therefore this point star point, and therefore graphite electrodes are replaced periodically. Therefore, graphite electrodes are replaced periodically. Graphite electrodes are replaced periodically. Replaced periodically. So check, a single example has taken a time of the 15 minutes. 5 minutes you people entered late, most of you. 15 minutes a single example explanation has taken. Graphite electrodes are replaced periodically. Why we have to replace the graphite electrode periodically?
Because the oxygen will react with the carbon of graphite.
So what happened? Let it react. Let it react. What is this? Why shall we replace? Let it react.
Because the electron will deplete and the reaction won't take place if the electron depletes.
Reaction stops. Yes. If you won't replace it periodically, and once the graphite electrode is completely consumed or eaten by the oxygen, the reaction stops. The reaction stops. And when reaction stops, again reaction won't start. If 1 second gap is also there in between that, reaction stops. Whatever the furnace it is there, in that furnace reaction stops. So very, very careful. Electrolysis is the example of a redox reaction. Both oxidation and the reduction should occur simultaneously. In between them, time gap or time lag should not be there. So if any one of the electrode is removed, maybe cathode or maybe anode, if any one of the electrodes are removed, ions will move in a random direction. Ions will move in a random direction and the reaction stops. And the same thing happened in the early 90s. In early 90s, a state it is there now called as the Chhattisgarh. Now called as a what? Chhattisgarh. Now also Chhattisgarh is a very, very famous for whom? Chhattisgarh. Naxals. Chhattisgarh is an hub for the Naxals are there, Naxalites are there, Maoists are there, red flag people are there, correct? Now also very famous. In that good olden days when it was not divided, it was still the part of the Madhya Pradesh was there. At that time it was highly horrible condition was there. I'm talking regarding early 90s, maybe 92 or 93 at that time, correct? Very horrible condition was there. They used to go to company and they will bury the red flag, that is Lal Salam, bury the red flag, and wheresoever the land they are burying the red flag, that land belongs to them. That lands belong to them. A very famous company was there called Sterlite. Very famous company was there called as what? Sterlite. And American company was there. And we are having Balco, Bharat Aluminium Limited. Bharat Aluminium Limited is what Balco it is there. Indian government has sold that Balco company, Bharat Aluminium Limited, to Sterlite, the American company, of 800 rupees crores. I'm talking regarding in the early 90s, 800 crores matters. Very, very big amount was there. Very, very big amount, because government owned company means government officials will come 1 hour late and they will leave the office 10 minutes before only. That is any government office that is there. So that condition was also there. So government thought if it will be sold to the private people, definitely something will be there. But in India, no private people was ready to invest that much amount of the money. And they have given to the American company, correct? American people knows very well how to take the work. They will put pressure on the government only, correct? And then this Lal Salam people came. This Lal Salam people, they have gone for the lockdown. Yes, lockdown. So lockdown means what happens? Any company rule it is there. If lockdown it is there, if workers are not working, engineers have to go and work. Whatever the job of the workers are there, that engineers have to work, but definitely each and every work engineers can't do. And after some days, whatever the suspended graphite rods were there, they were exhausted. Suspended graphite rods were exhausted, replacement was not there, reaction stopped. And here on the blackboard, I have drawn this much. Whatever the furnaces are there, they are equal to 6th story or 7th-story building. Not the diagram I have shown on the blackboard. 6 to 7-story buildings size of the furnaces are there. 3 or 4 furnaces are there of that size. In that 6 or 7-story building size, furnaces are there, and in that molten aluminium it is there. And now graphite electrode is exhausted. Now what will happen to the reaction? Reaction stops. That much amount has been solidified, because once reaction stops, cooling starts.
Yes.
When cooling starts, it's solidified, and then Sterlite company has backed out. And government has to paid 800 crores rupees again to that company. Again to that company was there. 800 rupees crore again. Then government thought it is better to eliminate the people than giving 800 rupees. And that is the reason why since late 90s, elimination started. Earlier, government was having only one mood to take them into the mainstream. Take them into the what? Mainstream, correct? But now, since the late 90s, when the government has observed these people are not observing the thing, or they are not listening, from that time onwards, elimination starts. And that is the reason why whomsoever the armed forces are there, maybe the police or maybe the army, in Naxal's area or on the border area, yes, number of times, not one time or two times, number of times, human right violation is happening. Number of times human right violation is occurring. Why? Because these armed people are there. They are at different place. Some, if suppose take example, myself, I am there. Let us suppose one Tamil Nadu people, it is there. Tamil Nadu soldier, it is there, or Tamil Nadu officer, it is there. He is there in Jammu Kashmir, correct? Or he is there in Chhattisgarh. He is having any idea regarding the local language?
No, sir.
No, sir.
Yes, sir.
When the local people are coming for the normal talk also, local people are there. They are not having the idea regarding the etiquette or the protocol that army people, it is there. I should enter very slow. I should first talk to them. First, I should lie down in this way and then talk. They're not having any idea. They're village people. They are tribals. They'll simply come to talk. So whomsoever these people are there who are not having any idea regarding the language, what they will feel? What they will feel?
They'll
That
think they're
these
the
people
Naxal.
are coming to attack me, correct?
Yes,
Yes,
sir.
sir.
And then they will fire, and they will not fire from this much. They are having the bullets of the size which will rip open the body into pieces. Not like normal bullet. They will get this type of the bullets which is ripped, in Hindi saying chithade uda dena. Chithade uda dena. Pat. The body will blown open. And after hitting also, on them police case is not there. On them police case is not there. Why? Because the government has given them that power.
Yes.
The government has given that power. It is there that whomsoever are there on the border area, or whomsoever are there on the counter insurgency.
1 minute, sir.
Excuse me.
Graphite electrodes are replaced periodically. Now I'll go for the Faraday's law, and Faraday's law, very, very simple formula based topic. And then I'll go for the Faraday's law now. Clear up this one?
Sir, 1 minute, sir.
Okay, better.
Excuse me, sir.
Tell me better.
Sir, graphite is an inert electrode, right? So how does it take part in the reaction or react with
Yes,
oxygen?
sir. Even I had a thought.
Where is the question of taking part? Graphite is not involved in electrochemical reaction. Whatever the oxygen gas is going up, that oxygen gas is reacting with graphite. That's all. What if graphite is not affecting the reaction? Graphite is not affecting this normal reaction. If the
Yes, sir.
graphite would have been affected, this cathodic reaction, the anodic reaction, then I would have been told it is an active electrode. This actual reaction not getting affected.
Yes, sir.
Yes, sir.
We expected aluminium at cathode, getting aluminium only. We expected fluorine at the anode, getting fluorine only. Yesterday, I have mentioned in CuCl to aqueous using copper electrode. At anode, we expected Cl minus undergoes discharge, but at
Yes,
anode,
sir.
we have observed copper undergoes
Yes.
oxidation. That is called as an active electrode condition.
Done, sir.
Done.
Now coming for the Faraday's law. So only formula part I'll give to you. Theory part you can see in the PDF file. According to the Faraday's first law, the amount of the substance may be deposited, may be liberated, or may be underwent cell reaction. The amount of the substance may be deposited at cathode, liberated at anode. So may be deposited, may be liberated, or underwent cell reaction is directly proportional to quantity of current passed through it. So if I write the formula, W is directly proportional to Q. W is the amount of substance may be deposited, may be liberated, or may be underwent cell reaction, and Q is quantity of current in coulombs. This information we are having. Q is equal to C into T. Quantity of the current in coulombs is nothing but quantity of current in amperes. Amperes in short is known as amps, you know very well, and time in seconds only. Very, very careful. This in amperes, this in second, this in coulomb. So 1 coulomb is equal to 1 ampere second. 1 coulomb is equal to 1 ampere second. So on the place of the Q, I can write as a C and T. So therefore, this will become W is directly proportional to C into T. On removing this proportionality, I'll put W is equal to ECT. It is there. I'll go for the one formula. And whereas E is our electrochemical equivalent. E is our electrochemical equivalent. If I want to define what is our E, it is there. So W is equal to E if C is equal to 1 ampere and T is equal to 1 second. So mathematically, I can define electrochemical equivalent is equal to amount of the substance deposited, liberated, or underwent cell reaction when current of 1 ampere is passed for the 1 second. It is there. This is the only way we will define our water terms in the mathematics or the physics. It is there now. Whatever this E is there, a small e is a capital E divided by 96500. This is the relationship between the small e and the capital E. Now question arises, what is capital E? Capital E is called as a chemical equivalent, or in our language, equivalent weight. In our language, equivalent weight. So you say equivalent weight or you say chemical equivalent, both are one and same. It is there. In the examination, a very common question is coming regarding a small e and the capital E. Mathematically, both a small e and the capital E is equal to W only. A small e is also equal to W. Capital E is also equal to W. Difference it is there that here we are having 1 coulombs of the current. Here we are having 96500 coulombs of the current it is there. So this is amount of the substance deposited or liberated when 1 coulomb of the current is passed. This is amount of the substance deposited or liberated when 96500 coulombs or from atomic structure 1 Faraday of the current is passed. From our stoichiometry, we know very well that equivalent weight is equal to atomic weight by valency. Equivalent weight is equal to atomic weight by valency. Keeping this in mind, keeping this in mind, keeping this in mind, now here I will write a multi-purpose formula. A multi-purpose formula W. On the place of the E, we are having capital E, it is this. On the place of the E, we are having capital E. Capital E is a transform into atomic weight into valency. So here I will write atomic weight. Here I will write valency. Here I will write 96500. This is a multi-purpose formula. Why it is multi-purpose formula? At the back of the book, they have given question based upon this. Almost all questions based upon this formula only. By this formula, you can calculate weight of a substance, atomic weight of a substance, current in amperes, time in second, and valency. Here I am writing valency. At the back of the book, some questions are there. There they have asked calculate oxidation number. So you say valency or you say oxidation number. In this case, one and same only. Anyone doubt here?
No, sir.
No, sir.
Shall I rub this one?
1 minute. The V is oxidation number.
V is oxidation number, valency or oxidation number.
Okay, thanks.
V is a valency or oxidation number. Once copied, let me know.
Done, sir.
Now I'll go for the another formula, and this another formula is an star mark formula. Number of questions you can solve by this. W is equal to E into C into T divided by 96500. Can I write?
Yes, sir.
Yes, sir.
We are having formula W is equal to ECT. We are having formula E is 96500. So on the place of the small e, I am writing capital E by 96500. C and T remaining same. On the place of the small e, this I am writing. So this formula is there. Now in this, just I'll go for the change of the position. This E I am bringing downside. This I am bringing downside. No, sir, here what famous it is there? Why the star marker? This is called number of equivalents. This is called number of equivalent. So, sir, what happened number of equivalents? It is nothing but indirectly normality you are getting. Why? Because from stoichiometry, you know normality, or from solutions and colligative property, normality is equal to number of equivalents into 1000 divided by VCC. Yes. This formula, it is there. And once you got normality, then you know formula. Normality is equal to molarity into n factor. Deliberately, consciously in the local examination, they will give some questions where they will ask conversion factor. They will give you something, they'll ask you something. So this is the way. So by this, you will get number of equivalents. From number of equivalents, getting normality. From normality, you can easily get information regarding the water. Molarity is there, and therefore this formula is so important. Shall rub this one?
This all is in first law only, no, sir?
All first law only. So this is the formula for a first law.
Yes, sir.
Now, shall I?
Yes, sir.
Yes, sir.
Now I'll move for the second law. Second law formula I have taught you stoichiometry. Yes, stoichiometry. Based upon that, number of questions in stoichiometry we have done. Number of questions in stoichiometry we have done. And now I'll go for the second law. Second law. Second law theory part is saying that if the same quantity of current is passed through different coulometers, coulometers is nothing but vessel. You say vessel, you say coulometer, or you say voltameter. Just technical languages are there, voltameter, coulometer, simply called as a vessel. If the same quantity of current is passed through different coulometers containing different electrolytic solution, solutions, and these coulometers are connected in series. Different coulometers vessels are there. In between them, parallel connection is not there. Series connection it is there. From the physics, you know very well what is the meaning of the parallel connection, what is the meaning of the what series connection. Again, I'll repeat. If the same quantity of the current is passed through different coulometers containing different electrolytes connected in series, the amount of the substance deposited, liberated, or underwent a cell reaction is directly proportional to equivalent weight of the substance, or W by E is equal to constant, or W1 by W2 is equal to E1 by E2. Remember, in stoichiometry, based upon this questions we have done.
Yes.
This is our second law. It is. So second law is a straight away giving information regarding the weight and the water equivalent weight of the substance. It is it. Now coming for general point. This general point is an understanding point, shortcut point. Straight away, it is giving a lot of information. It is there. 1 Faraday of the current when you are passing, 1 Faraday of the current is nothing but 96500 coulombs. 96500 coulombs means Avogadro number of electrons. So this much current or this much current carries how much charge? Avogadro number of the electrons they carries, and this is equal to 1 gram equivalent weight of substance. Again, I will say 1 gram equivalent weight of substance does not mean 1 gram. Equivalent weight in terms of grams. So when you are passing this much Faraday, 1 Faraday, the amount of the substance deposited or liberated will be equal to equivalent weight in terms of grams towards blackboard. 1 Faraday means 9 grams of aluminium. Can I say?
Yes, sir.
Yes, sir.
Atomic weight of the aluminium is 27.
27
Valence 3. 27 by 3 is equivalent weight of the aluminium. So 1 Faraday will go for the 9 grams of the aluminium. 1 Faraday will go for the 8 grams of the oxygen, because equivalent weight of the oxygen is 8. 1 Faraday will go for the 35.5 grams of the chlorine. 1 Faraday will go for the 23 grams of the sodium. So 1 Faraday will always liberate or deposit 1 gram equivalent weight of the substance, or equivalent weight in terms of the grams. Anyone doubt?
No, sir.
Now I'll go for some typical questions. So typical questions which are coming in the examination, that straight away I'm going for. straight away that questions I am going for, so that you should not do mistake. Straight away, all of you open objective fourth. Straight away objective fourth. Not 1, 2, 3, straight away fourth. And that some typical questions are there that they are mostly asking in the examination. Why? Because they knows very well that most of the lecturers won't go for the objective 4. They don't know Sanjay Singh is there. You are taking out question number 20, question number 20, question number 22.
Page number, sir.
Page number 227. Objective 4, page 227, question number 20 and question number 22. So first, all of you read question number 20. Read question number 20, then I'll help you. Once reading part is over, let me know. I have never told you to solve the question.
Yes, sir. Done.
Just go for the reading part.
Done.
Done, sir.
I'll go on solving the question. Tell me, by reading the question, what is the main question asked?
Yes, sir.
Question is pH. Question is what? pH. Let us go for here some rough work. Sodium chloride aqueous electrolysis. Sodium chloride aqueous electrolysis forms a sodium hydroxide. Am I correct?
Yes.
Yes, sir.
This you have to know. Yes, this you have to know. Sodium chloride aqueous solution electrolysis, you are getting sodium hydroxide. Yes, otherwise what you will apply the pH? Acidic, basic, what will apply? So sodium chloride electrolysis forms sodium hydroxide, means the corresponding solution is basic in nature. Corresponding solution basic means pH will be more than 7. pH will be what? More than 7. This is the way we can go for the elimination technique. See your bad luck. All the 4 options are what? More than 7 it is there. Now going for the solver. W by E is equal, I'm sorry. In this case, I won't go for the W by E. In this case, I'll go for in this way. 1 Faraday is equal to equivalent weight. 1 Faraday is equal to equivalent weight. So 0.0 Faraday. So can I say 0.04 equivalent weight? Can I say?
Yes, sir.
So from here, you are having a very clear information regarding equivalent weight, or equivalent weight means it is number of equivalent. So 1 Faraday is equal to 1 Faraday is equal to 1 equivalent. So 0.0 Faraday means 0.04 equivalent. So by this we got information number of equivalents, and now I'll go for the number of equivalents into 1000 divided by VCC is nothing but normality. Number of equivalents is 0.04 into 1000. VCC is nothing but 400. So can I say it is 0.1?
Yes.
Yes, sir.
This 0.1 is nothing but hydroxyl ion concentration. Why hydroxyl ion concentration, sir? Sodium hydroxide. So this theory part should be there inside the mind. That is the reason why 1.5 a day, 3 classes I have taught you electrolysis only, 3 classes by giving PDF file also. 3 classes I have taught you, because this is the basic part. Faraday's law is not basic, it's a straight formula based questions are there. But for solving the question, this concept you should know. When we got this one, based upon this, can I say POH is equal to 1? Can I say?
Yes.
Yes.
If POH is equal to 1, so can I say pH is equal to 30?
It's 14 minus 1.
Yes, 14
Yes.
minus 1, it is 30. After copying this question, all of you read question number 22. All of you read yourself question number 22 and tell me in this case what is asked.
Yeah.
pH of the solution. Of
pH
the
of the solution.
In this case also question is asked to calculate pH. So in this question again asked pH, again help of electrolysis. Again help of electrolysis.
Sulfuric acid.
And that is copper sulfate aqueous on
H2SO.
electrolysis gives sulfuric acid. Blue vitriol I have given to you. So copper sulfate
sir.
on electrolysis gives sulfuric acid. Sulfuric acid means hydrogen ion concentration. In this case, I'll apply this formula. W by E is equal to C into T 96500. No, sir, why applying this formula? Because in this question, they have given current and the time. In the previous question, they have not given current and the time. That is the reason why I have gone for another way. What is the current in this question they have given?
9.65 ampere.
9.6.
9.65. What is time they have given?
2 hours.
20 minutes.
2 hours.
23600.
Time should be always in second. Current should be in amperes. Basic thing you should not forget. How much equal to? 0.72?
Yes, sir.
This is number of equivalents. Normality is equal to number of equivalents divided by straight away volume in terms of liters. Here straight away I am going for the liter. Why? Because in the question volume they have given in terms of liters. If they're giving in terms of cc, then I will say into 1000 divided by pcc. So here they have given 0.72 and here they have given 72. Can I say 0.1? Can I say 0.1?
Yes, sir.
Yes, sir.
Yes.
So hydrogen ion concentration 10 to the power of -1. In the previous case, I have mentioned hydroxyl ion concentration 10 to the power of -1. In this case, hydrogen ion concentration 10 to the power of -1. Why? Because it is a acid, sulfuric acid. No, sir, but here we are having 2 hydrogen. Here, why writing 1 hydrogen? A is normality. You are calculating normality. N factor does not come in picture when going for normality. If it would have been molarity, I would have been multiplied by 2. Straight away, I am calculating normality, and therefore, straight away, I'll say pH is equal to 1. Because n number of times in the class I have repeated, pH should be always calculated by normality concept. Solubility and solubility product should be done by our by molarity concept. That's correct. By molarity concept. By molarity concept. Very good. Now coming for question number 19. This too I have done for you. Question number 19, you try yourself and tell me what is the answer. Take time of 1 minute. After 1 minute, I'll help you. Your trying is very important rather than myself solving each and everything on the blackboard.
Sir, same, but into 2 we should do.
Huh?
Into 2 we should do just now, sir. Means molarity.
I am not bothered. I am bothered regarding answer. That's all. How you are doing, I'm not bothered.
So 1M.
1 m.
1m. Chalo, let us go for the 1m. Let us go for the 1m. How 1m? Let us go for the how 1m. Let us go for the how 1m. Let us cross check it. Let us cross check it. In this case, we are not bothered regarding pH. So in this case, we are not bothered regarding hydrogen ion concentration, this and that, not bothered. Whenever they are asking pH and all these things, then we should go in the detail after electrolysis what we are getting. This is a straight question. This is straight question. Now let us go for the current. What is current they have given? 965.
965.
What is time they have given?
100
100
seconds.
So can I say number of equivalents is 1?
Yes.
Yes.
Yes, sir.
So now I'll go for the normality is equal to number of equivalents into 1000 divided by VCC. So number of equivalents is 1 into 1000 by 500 by 500. Can I write?
Yes.
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 So can I say normality is equal to 2?
Yes, sir.
Yes, sir.
Now I'll go for the concept. Normality is equal to molarity into n factor. So molarity is equal to normality by n factor. Normality is 2. N factor is also 2. For copper sulfate, can I say n factor is 2?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
So this is very clear. From 2m solution, 1m solution is deposited. From 2m solution, which we have taken earlier, this 1m electrolysis was deposited only. Cu plus 2 will now become copper. Cu plus 2 will become now copper. So from 2m solution, 1m is deposited. So can I say, therefore, concentration of Cu plus 2 left is 1m.
Yes.
Can I say
Yes.
why I am saying left? Question is saying after electrolysis. So out of the 2m, 1m has been deposited. So what is left over? Is 1m. Most of you have left here only and got the answer 1m. It's mere coincidence it is there that your answer 1 is correct for most of you. If suppose in the question on the place of the 2, if they would have been given 4m,
3.
then answer would have been 3m.
Yes, sir.
Yes, answer would have been 3m, not 1m. Here very clear it is there. You got 1 and therefore answer is also 1. Why? Because 2 minus 1 is 1. But this is not the step. This is the last step. From 2m solution, 1m solution is deposited and therefore concentration of the copper ion left is a what? 1m it is there. Done?
1 minute. Done, sir.
So whatever these questions I am doing, I am not going for doubts clarification. Not doubts clarification, it is sample questions only I am going for. Today evening also I'll go for sample questions and I am very sure that Rahim sir has put a message yesterday evening only.
Yes.
Yes.
Yes,
Yes,
sir.
4
What
to
is
5.
time?
4 to 5.
4 to 5.
5. Sharp 4 o'clock I'll be in the class. Don't give me the reason, no, that madam or that sir is late. Inform them. Inform them that Sanjay Singh is awaiting. Inform them Sanjay Singh is awaiting. They are coming 5 minutes, 10 minutes late, therefore they're leaving 10 minutes late. But for me, that condition is not there. No? I'll come on time, leave on time. And leave on time. So meeting at 4 o'clock and 4 to 5. Because 5 I'm having other classes. So guarantee I won't take 1 minute also extra time for you. 4 to 5 again I'll go for solving some sample questions only. Yes, complete 1 hour I will only go for solving some sample questions. Today evening you will try the leftover questions and then if any doubt it is there, again tomorrow I am having 2 classes. One is the original and the evening original study hours.
Okay.
Yes, evening original study hours. For today evening, you are trying after my class more and more number of questions so that tomorrow you can clarify more and more number of doubts. Let us make today evening for solving some of the good sample questions from topic electrolysis, and the Faraday's laws.
Okay. Thank you.
So,
Bye.
thank you.
Thank you, sir.
Thank
Bye,
you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye,
Bye,
sir.
sir.
Thank you, Vita. Bye bye. Thank you.